1, 2, 3. 1, 2, 3. Put it down, put it up. Okay. I wait for a signal from your side then. Yeah, sure. No problem. Okay, then once again, hi. I'm Enno. I'm going to talk about kid tracking technologies and their risk and applications, which is a pretty uncommon subject for a talk, at least for me. So I'm glad to see some people here. I mean, it's a uncommon subject for a talk, and it's a first talk on the second day, which is thankless, the schedule point, kind of. The agenda is I want to introduce you to the technology, then I'll talk about some approaches, how to get a feeling if the technology is a good thing or a bad thing or something. I'll take something like a hacker's approach, how to attack this kind of a technology. I'll take the risk analysis approach. Is it good or is it bad? What's the benefit? Do we gain something as for safety or security of kids, or do we even maybe lose? And last but not least, I'll give some kind of notes on the social implications of that stuff. That stuff has been covered elsewhere much better than I can, but just to throw in some personal notes on the social implications. Some words on my person. I'm a kind of, usually I call myself an old school networker. That's what I am. I like working on layer 2 to 4. Everything above that is some strange applications stuff I do not understand really, and I do not care for. I'm a frequent speaker on different conferences. Usually I have subjects like MPLS security or voice of IP security, virtualization security, stuff like this, and there I have some demos, so at least in this talk, even though it's a bit uncommon for me, I don't have any demos, so don't expect any practical stuff here. It's a purely theoretical talk, which might turn into some practical stuff later in some years. Some notes on the background. I had some discussion with my wife. We have 2 kids. On this technology, would it be a good thing to be able to track the kids? I mean, every mother is scared about kid getting kidnapped or having an accident, being somewhere without being able to contact the doctor or whatever. So there is some pretty appealing aspect in that for parents. And I had, when we talked about that, I did not have, let's say, a good feeling about that. I thought, oh no, I don't like this stuff. There is, that's strange. And I had to convince her why it is strange. And I wrote down some things. And being in Dayton in the last days, so I knew I had some work to be done in Dayton in April. Brian, Angus Fight, he told me there was a cool conference, NotaCon, going on, and maybe this could be a good place to talk about this stuff, and that's why I'm here. So into the technical details, those technologies I call kid tracking technologies are a kind of subset of technologies which are sometimes have the title location-based services, which implies location, locate something, and then offer some service based on the location. Maybe locate if somebody is in his office or he's not in his office, and then redirect the call. This is a simple example of a location-based service. And these location-based services usually locate some kind of asset, some kind of electronic piece that's located. One could be tempted to replace that electronic piece by locate a human, but in fact it's still the electronic piece you locate. It's not a human. Maybe it's a human who carries it, but it's still the electronic piece, and this may turn out interesting in a security context later. The communications protocols which are used might be RFID with implants on a short range. They might be Wi-Fi, WiMAX, Bluetooth. There is a whole space of location-based services built on Wi-Fi that's currently evolving, and it might be GPS. Those are the three main, let's say, protocols involved. And we have some components, usually just some kind of sender. Throughout the talk, I'll mainly talk about those senders used as implants. This is a picture from a guy, pretty prominent for the RFID stuff he does. He even wrote a book, RFID Toys. That guy has RFID implants in his hands, which are here X-rayed, and he uses that stuff for access control to his house and to start his car and stuff like this. So there is some sending instance. There is some communication means. There is a receiver receiving the signal, and some backend database. These are the components included in the whole picture. With RFID, you usually there is some specialty that the sender, or the tag, as it's mostly called in RFID context, gets its energy from the so-called reader, which might not be only a reader, but also a writing device. But that's the same thing as with smart card readers who don't necessarily read. It's not a right term, but a common term. With our RFID, as I said, the specialty is the thing receives its energy from here, from a magnetic field, so it doesn't need an internal energy source. What does happen? That sending instance, that sending device stores some data, which might simply be an ID consisting of 32 bits, for example, and there may be additional data, for example, medical records on that sending device. This ID, and if needed, the data is transmitted to the receiver. This receiver might be, in the case of GPS, it's a satellite. In case of RFID or Wi-Fi, might be some receiving entities in public spaces. Whenever you enter a building, you pass through with your RFID tag, and so you can be located. This guy is in this building currently. When you leave it, again, and some read access to that device, and so it gets known you're no more in the building. So it might be gates, it might be a satellite, some point where you transmit your data to. The ID, in case of RFID, might be usually is mapped to a set in a database, which identifies the asset further. So it might not be your personal data, like your name on the tag, just the ID. But once you identify that ID in the database, it's clear, okay, that's John Miller from Cleveland. He has that age. He has those medical records. So all the stuff usually is in the database. It's not on the tag or sending device. And the exact location, then, this is the whole thing. Exact location of that electronic piece may be located and tracked and displayed in some sense to authorized parties, maybe via web interface. A mother of a kid might be able, okay, I want to know where is my kid currently, logs into some SSL page, and there's a land map, and you can see, okay, my kid currently is on the way home, or is still in school, or is out at a swimming pool, or whatever. This is what the whole thing is about. There's a lot of standards in the RFID space. The standards itself are not important here. it's more important there is a lot of standards which might lead to incompatibilities and stuff we will cover later. This is just to give you an idea how the data is organized on those tags. There is some serial number, and one might be, depending on the standard, might be able to store data on tags. Short comparison of the communication technologies as for their range, those technology I mentioned, as for their power source. With RFID, there's no power source. With Wi-Fi or GPS, you need a power source, which might be a problem when it's in your body. As I already said, I'm going to talk about implants. But technology evolves, and there are plans and technologies which might enable you to have something like in this size, like a piece of a finger, somewhere within your body, which has a small battery and is able to transmit data within a given range. So what's the purpose of this stuff? Kid tracking in case of accidents, or let's say human tracking, which may be kids. This is the main subject of my talk, which may be delinquents on probation. There it's currently used, already used. Prevention of kidnapping by tracking, being able to track kids, or access control. Big thing in all that is access control, access to buildings. The Mexican general attorney had such a thing implanted 2 years ago to be able to access rooms with classified data. And him and some employees got implants. So one could control who can enter some room just by that implant and an RFID set. Access to laptops. This is what that guy does, where I showed the X-rays. At ShmooCon, there was a guy who got access to his laptop by some implant he had somewhere in his arm. And Major Malfunction cloned that later on, which was funny. But I get back to that. Or that might simple control to access to drinks at some stuff like RoboBar. I'm not sure if you heard of RoboBar. It's as the name implies, a kind of automated bar where you can get drinks 24/7. But this stuff has to check: is the person who wants to get a drink allowed to get a drink as for the age? And so you might have some implant. Just show it to the RoboBar. This implant or the database tells, hey, I'm more than 20 years old. I should be able to get a drink. So control of access to something is one of the big purposes of this technology. Some examples where this is already used, mostly in the form of badges, not implants. But the next step, lots of companies and researchers are envisioning is do all this stuff with not with badges but with implants. Delinquents on probation, there is already used. They are allowed to stay at home, so you save a place in prisons, but they are not allowed to leave their homes. So they have some kind of bracelet, and whenever this bracelet gets out of range of some receiver, some authority might be informed, hey, he's leaving his home. There was some stuff with kids at some school in California where the kids got equipped with bracelets to be able to track them within the school. There were a lot of parents' protests, and that's why they stopped the project. There is some stuff, the Ottawa Citizen, where Alzheimer patients got bracelets to be able to track them once they get lost. The FDA has admitted special chips for medical records, implants in fact. That stuff is about implants. Such an implant could look like, you won't be able to see it from more than some meters away from me, but to give you an idea, this is the stuff I'm talking about as for implants. Yeah, Brian. You can easily inject it with a needle, and remember that picture of the guy. There are some theme parks who give